Hi, I'm going to walk you through our NXP Modular Gateway demo. So with this demo, what we're trying to demonstrate is a gateway application into a industrial IoT application, for instance, something like in building control, and in this case, a large node lighting array. So pretend you're walked into maybe an unfamiliar building with into a conference room, and you want to turn the lights on, you can't find the light switch. So what if you could turn those lights on with either your voice or with a smartphone application? We can enable that here. So what I'm going to do is pick up my Amazon tab, which is powered by NXP IoT 6 processor. So I'm going to go ahead and prompt it. Alexa, ask all devices.
Welcome to NXP Modular Gateway demo.
Blue.
Changing Thread and Zigbee devices color to blue.
Some of y'all saw how fast that was in the background, but it was pretty snappy. That's a cloud command to the cloud and then back down to the gateway. So I also have similar control here with my smartphone application. So if I back out here and I go to my smart controller, I can do things like come here to the thread nodes, turn all those thread nodes red, and then similarly for Zigbee, I can go blue. So this is all enabled by a confluence of technology inside of our IoT gateway, our modular gateway driven by an IoT 6 UL processor with our KW41Z and JN5179 modules. The key NXP technologies we're demonstrating here are first our robust Zigbee and thread stacks, in addition to some pretty cool multicast messaging we're doing to control this large node lighting array and pull off those snappy effects. And then finally what we've integrated into this is NFC for commissioning. So with these large deployments like a commercial lighting application into a large building, you really need the ability to quickly commission these devices, sometimes hundreds, even thousands with workers. You need them to be able to do that accurately and quickly, sometimes even without power. So let me go ahead and show you a demonstration of how we were able to do that with our NFC InTag I2C technology. So I have my commissioning demo here. So the first thing I'm going to do is in our demo here, we've randomly selected a Zigbee and a thread node in our main array, and we're going to decommission them and replace them with two bulbs I have here in this display unit. So the first thing I have to do for each unit is install some manufacturing time data. For instance, in this case, I'm telling each node what it needs, the credentials it needs to join the network and become part of it once it arrives at from the factory to the building deployment. Okay, so then the next thing, now the bulbs have showed up at the factory, now I need to install them. So basically what I'm going to do here is I go find my bulbs. So for the Zigbee bulb, just with a long press, so I'm reading out the manufacturing data. It's merging that with where I want to put it in the array, and then it writes that back into the InTag. And then similarly, I do the same thing for the thread node. Do a long press, read the manufacturing data, amend it with the location where I want it to be, write it into the tag. So now I would add power to the lights. I do a quick run here to sync the cloud connection in my gateway to tell them the devices that I've decommissioned and replaced it with on the deployment. And then now I should be able to come here to the control screen. And for instance, I go to blue. So right here, you'll see that my Zigbee node at 5-4 has been decommissioned and has been replaced with the bulb that I have here. So that's it. It's just an example of how we can use a confluence of NXP technologies to solve a much bigger problem. So this was a large lighting node network demonstration, but this technology is applicable in many other areas such as smart cities, smart meters, smart pharma or agriculture, even oil and gas. So if you guys have any more questions about this, please visit our website at nxp.com/modulargateway.